What happens after we die? Well, imagine this. Your heart just stopped. 1 second it's beating, and literally the next second it's not. Boom. That fast, that simple. Right now, we're looking at the stark reality of what medical professionals call second zero. It's the exact, precise moment your heart abruptly stops beating. And what happens over the next 60 seconds is something science is only just now starting to truly wrap its head around. Because as it turns out, the moment you cross that threshold might actually be the most alive your brain has ever been. We're going to unpack this whole process using some absolutely incredible recent research. We're taking this data incredibly seriously to give you a clear, grounded, scientific picture of what actually happens in those crucial first moments. So let's track this on a timeline. We're going to follow a precise 60-second chronological countdown of clinical death. We'll be tracking two things at once: the physical cascade happening in your cells and the honestly shocking neurological changes happening inside your head, right up to the 60-second mark. Okay, let's dive right into second zero. The very first thing that happens when your heart stops is, well, essentially nothing you can physically feel. Your blood pressure drops to absolute zero. The 5 liters of blood that were happily circulating through your body just a fraction of a second ago are now sitting perfectly, completely still. Without a pump, there's no flow, and there are no new deliveries of oxygen. But here's the crazy part. At this exact moment, your brain doesn't know that yet. For those first few seconds, your brain is still running. It's basically coasting on whatever residual oxygen happens to be left in that stagnant blood. You are still, technically, you. Now, to understand why your brain reacts the way it does next, you have to know this vital number: 20%. See, the brain is absolutely the most oxygen-hungry organ in your entire body. Even though it's relatively small, it's a gas guzzler, consuming a massive 20% of your total oxygen supply at any given moment. Because it's so incredibly demanding, it's the very first organ to notice when those oxygen deliveries stop. It simply cannot survive on residual fumes for long. As we hit the 10-second mark, we see this massive divergence. The cerebral cortex, that's the part of your brain responsible for your conscious thought, begins to shut down. From the outside, you lose consciousness. Your eyes stop processing images, your ears stop registering sound. To anyone in the room, you look entirely gone. But the inside view, that tells a totally different story. Deep within, there's actually highly organized brain activity, surging neurons, and the very real potential for intense internal awareness. Let's look at the hard data behind that inside view because it's fascinating. In 2023, a neuroscientist named Dr. Jimo Borgigan at the University of Michigan published a groundbreaking study that totally flipped how we think about dying. Her team actively monitored the brainwaves of 4 comatose patients as they were taken off life support. Now, medically speaking, they expected to see a quiet fade to black, right? Like a machine slowly losing power. But that is not what happened. In 2 of the 4 patients, within seconds of losing oxygen, their brains literally exploded with activity. Dr. Borgigan herself was pretty blunt about it. She actually described the surge as, quote, crazy high. So what exactly were they seeing? They saw a massive spike of gamma waves. And guys, these are not random dying misfires of a broken brain. Gamma waves are fast brain waves deeply associated with consciousness, heightened awareness, memory retrieval, and dreaming. And the kicker? This activity was highly organized. It was concentrated specifically in a region called the temporal parieto-occipital junction. That's a mouthful, I know, but previous research has linked that exact area directly to out-of-body experiences and visual processing. The brain wasn't powering down at all, it was lighting up in the exact spots responsible for our most complex conscious experiences. And what's wild is that this hard scientific data perfectly aligns with what people have been reporting for decades after being brought back from clinical death. We've all heard the cliche, right? Your life flashes before your eyes. We usually assume that means the highlight reel, your wedding day, graduating, your greatest hits. But survivors say that is not how it works. It's the mundane, small moments. There's this one famous anecdote of a young man who was resuscitated, and he described his life review. He vividly remembered seeing a white cat on a staircase. He couldn't place the memory at all. But after he recovered, he described the apartment layout, the stairs, and that cat to his mother. She was stunned. She confirmed that they had lived in that exact building next to a neighbor with a white cat when he was only 14 months old. No way he should logically remember that. Which obviously leads us to this huge, profound question. Does the dying brain, in this intense final surge of gamma wave activity, somehow unlock our entire archive of memories? Like, every single one? Neuroscience absolutely doesn't have all the answers to this yet. We don't fully understand how a 14-month-old's totally forgotten Tuesday afternoon gets perfectly preserved and suddenly played back in high definition. But what the brainwave data absolutely confirms is that something is happening that goes way, way beyond a simple biological shutdown. Moving on to the 30-second mark. The body relaxes. While the brain is throwing a fireworks show, your cells are starting to panic. By 30 seconds, your blood isn't carrying oxygen anywhere. All 37 trillion of your cells are noticing the deprivation. So they pivot. They switch from aerobic to anaerobic respiration. This is basically a cellular backup system that lets the cells squeeze out a tiny bit of energy without oxygen. But the cost is incredibly steep. It causes a rapid, massive buildup of lactic acid, which immediately starts flooding your entire system. And that chemical shift triggers immediate physical changes. Because the muscles are no longer getting any instructions from a functioning brain, they completely give up and relax. The jaw drops open, eyelids go slack. If you were standing up, you've definitely fallen by now. And most remarkably, your pupils dilate and become completely fixed. The muscles that adjust your pupils to control light, gone offline. Your eyes, even though they're structurally completely intact, are now just empty lenses with no one behind them. Let's look at some more data with the AWARE-2 study. Dr. Sam Parnia is a resuscitation researcher at New York University, and he's spent over 2 decades rigorously studying what happens to consciousness during cardiac arrest. In 2023, he released the AWARE-2 study. It examined hundreds of patients across 25 different hospitals, making it the biggest study of its kind. And guys, the numbers are shocking. Even though these patients were clinically dead, heart stopped, zero outward signs of life, roughly 40% reported some perception of consciousness. About 20% described a highly structured, recalled experience of death. And a wild 3% reported full visual and auditory awareness. They could actually see and hear what was happening in the room around them, even though their brains were showing absolutely no visible signs of activity to the doctors standing right there. When you dig into the accounts from that 20% who recalled their experience, the consistency is almost eerie. Here's what they say. They very often describe seeing a deceased relative, like a parent or grandparent who acts as a sort of guide. They report a feeling of overwhelming, deep peace, and specifically note a total lack of pain, darkness, or emptiness. And many report being told by these figures that it just wasn't their time yet. Now, looking strictly at the data, science remains completely neutral on whether this is just the brain creating a final comforting hallucination or if it's something else entirely. We just don't know. But what the data confirms, without a doubt, is that the experience for many is overwhelmingly peaceful. And that brings us to minute 1, biological limbo. At the 1-minute mark, the damage to your cells is getting serious. But, and this is key, it's not permanent yet. You aren't alive in any traditional sense, but you aren't irreversibly gone either. You've entered this extremely tense 4 to 6 minute window. Brain cells can survive without oxygen for roughly 4 to 6 minutes before permanent, irreversible brain damage sets in. Because your body temperature has barely changed yet and your skin is only just starting to pale, resuscitation is still highly possible right now. If someone starts CPR or uses a defibrillator, the whole process can actually be reversed. But the clock is absolutely ticking. Down at the microscopic level, a tiny point of no return is just barely starting. We call it autolysis, literally self-digestion. Remember that lactic acid buildup we talked about inside your cells? It's weakening your cell membranes. Destructive enzymes that were safely locked away are just starting to leak out, which causes the cells to literally begin breaking themselves down from the inside. So at exactly 1 minute, we're looking at 2 simultaneous realities. The medical reality is incredibly hopeful. Your cells are mostly structurally whole. They're just waiting. They're waiting for oxygen to be restored by a doctor or a paramedic. People come back from this reality every single day. But the final reality is absolute. If no one comes, if there is no CPR, then those past 60 seconds, well, that was your last minute of existence on this side of life. And if it was your last minute, decades of rigorous scientific research leave us with this verified takeaway. The brain did not use that final minute to just shut down quietly. No, it used it to turn on. It rallied, it surged, it processed memories and created profound states of awareness, all in the face of total, catastrophic physical system failure. Which leaves us with something pretty profound to think about. The people who come back from this don't return wanting more money or better jobs or more status. They come back wanting more time, more presence in the small moments that didn't seem to matter at the time. Because as we've learned, those are the moments that flash before your eyes. So I'll leave you with this question. Are you fully present in the ordinary Tuesday afternoons your brain is currently recording? Because your brain is archiving all of it right now. And in your final minute, it just might play it all back. Take that with you today. Keep learning, keep asking questions, and value those everyday memories. Catch you in the next explainer.